All right, so nice. So what is a locus, right? I'll give you an example here. All right. So if you look back here, right? If you look back here, you should be familiar with this one, right? I'm going to give you what is a locus. So if I give you a set of points, right? And I tell you this point P is always equidistant from this unknown. Let's call this unknown R, right? So this point P is always, no matter how it moves, it's always going to be the same distance away from R. Okay? So it might move something like this. Correct? What does it trace out? It will trace out a circle. Right? So what is the locus? The locus is the path that a point will trace out when given certain conditions. That's okay? So if I tell you that this point P is always equidistant from this point, then the path that that point P will trace out is called a locus. Are you okay with that? Yeah? Write this down. The locus of, I say spell it, right? Some locus you can figure it out one time by just watching the definition. Some you'll have to work out. All right. So the locus of a point, the locus of a point is the path. If you can't spell it, it should be the correct. It's the path the point will trace out. It's the path the point will trace out when given certain conditions. When given certain conditions. When given certain conditions. That's okay? Sometimes we have to figure out what is it path it will trace out, right? So for example, the path traced out, the path traced out, the path traced out when a point P is always equidistant from a point C, when the point P is always equidistant from a point C, it traces out a circle. It traces out a circle with center C and radius, whatever that distance was. Let's call that D, right? With a center D, with a center C and radius D. All right, so before I give you some standard ones, let's start with this one here. What is the locus in this case? Right, it's P is always 3 units away from 2, 3. P is always 3 units away from symmetry. Okay? You all can watch this and then notice a what? You can watch it and then notice a circle with center and radius 3. Right? But we can also prove it. Here's what you can do. Right? You just plot 2, 3. Let's say 2, 3 is here. And P is somewhere here. Right? And this distance is always going to be 3. How do we find distance between 2 points? Online, you're here, right? Emily? You're here? How you find the length or distance between 2 points?
X2 minus X1.
Right. So P is a random point, right? P is a random point, X, Y. Right? So the formula is what? The square root of X2
Minus X1 squared.
plus equal to, that's okay? I can square both sides. Square both sides. What do we have? We have a circle, right? So we have a circle. We have a circle with center 2, 3, and radius. Sorry, that one, right? Radius 3. Okay? So I showed you how to prove it, right? Okay, so sometimes you can work it out, sometimes you just, sometimes you'll know it, right? Based on the conditions. Right, online, you're hearing clearly, right? Amanda? Yeah? All right, so sometimes it's a circle, sometimes it's a quadratic, sometimes it's a parabola, sometimes it's a ellipse, sometimes it's a straight line. Okay? Let's see if we can figure out what this one is. Number 2, right? Find the locus. Right? P is always the same distance away. P is always the same distance away from from 2, 3, and what do I want to work with? 5, 7. right? 5, 7. So it's always the same distance away from 2, 3, and 5, 7. What did we end up with now? So what's this here? I didn't give you any value for D, right? For distance between them. So we need to find a way to get an equation given this information. So here's what you can do. Shavish, you watch it? It'll be accurate. Yeah. So from here to here, that distance, let's call it T. All right? Based on the information, Shavish, what's the distance from here to here? Same. Is there any way we could get an equation? Right? So could we use these 2 points, this on xy, and find D, and use this and find D, and then do what with them? Equate them. And something magical will happen. It's very magical stuff. Try that here online. Try that here. Let's see what we will get. Right, so I want to see what we come up with. Equate them and find a way to simplify them out. It's a little longer. Alright, take your time and set it up. Huh? So the first one is what? G is equal to the square root of x minus 2 plus y minus 3 squared. And then if you use here now, square root of, leave the x first up, x minus 5 squared, y minus 7 squared. Everybody get it online? Right, so you can equate them and let's see what you get. equate 1 and 2 and let's see what you get, right? Remember, you'll get an equation, so you're not solving anything. Right? So you're going to square both sides. When you square both sides, you get rid of the square root, right? Okay? You'll get rid of the square root and then you have to square everything out. Square it out, tell me what you get. Anybody get something online? Right? Let's see what equation you get. Right? So when you square both sides, you'll get rid of the square root, right? And then all we have to do is expand this out. We'll get x squared minus 4x plus 4 plus y squared minus 6x, sorry, minus 6y plus 9 is equal to x squared minus 10x plus 25, y squared minus 14y plus 49. You will see immediately that the squares will cancel off. Right? Bring all the x's together now.
Yeah, 6x.
So you'll get minus 4x plus 10x. You'll get minus 6y plus 14y and bring all the constants on one side. That's 25 plus 49 minus 4 minus 9. Right? So you'll get 6x plus 8y is how much here? How much? 51.
61.
61. What are this? What is this here? A straight line. A line, right? So this will probably form a line. Okay? Not a circle, a line.
Yeah.
That's the answer, a straight line. Right? So you can just tell them a line. You can only greater than y into subway obvious, right? That's okay? Online? Are you okay there? All right, take a small note on 3 standard Locus that I should do. Some more just now. Right, these are 3 standard ones that you should know. Number 1, a circle equidistant from a fixed point. A circle always equidistant from a fixed point. 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 Ellipse. 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 Sum of the distances. Sum of the distances. Right, for the ellipse, the sum of the distances from 2 fixed points, is always constant. It's always constant. It's always constant. Right? That is the ellipse. And third one, parabola. Parabola is always equidistant. The parabola is always equidistant from a fixed point and a fixed line. From a fixed point called the focus. From a fixed point called the focus. And a fixed line line, like a straight line, and a fixed line called the directrix. Direct and trix. Directrix, yes. Which one? From a fixed point, call it focus, and a straight line, call it directrix. And a straight line, call it directrix. Okay? So those are the three standard ones that you should know, right? Let's experiment with one of them. How you draw the line x equal to 1 again? How you draw the line x equal to 1? Right? Find x as 1 and draw a horizontal line. Huh? Yeah, where'd it go? Yeah, I said you. Sorry. Right. So, quick question. If you had to guess, what's this point here? Well, you sure is 1, eh? 1 what? 1 y. You sure is 1 y. Right? Or you sure here is? Here. You sure here is what? 1. X is 1. 1 y. So anywhere on this line is always what? 1 y. Okay? So anywhere on this line is 1 y. So let's say we have a point 1 y and we have a point 4 2. Right? And we have the point P. P is xy, of course, and P is always equidistant from this line and this point. See if you can find that, Lucas. So P is always equidistant from this line and this point. Try to find the locus. It's always equidistant from this point and this line. Try it and see. Try to see what that equation will be that locus. Okay? So it's always equidistant from this line and this point. Try that, please. Equidistant means what? The distance between is the same. So you're doing it just like this. One is B and next one is B and equator. All right? The equation will look slightly different. Ariane now join it. Right? This is the last thing in geometry, right? Then it's vectors. Should we try the thing now, boy? Find the same thing. Find D from P to 4 2 and P to 1 y. Right, remember, I just gave it this, so you have to figure out this so regardless of what type of line it is. Okay? So find D in each case. Right? Okay. All right, so let's see what we got between here and here. It'll be, all right, the square root of x minus 1 squared plus y minus y squared, right? And that is the same as here to here. That's the square root of x minus 4 squared plus y minus 2 squared. Right? Square both sides, and you'll get x minus 1 squared. This is 0. Is equal to x minus 4 squared plus y minus 2 squared. Oh, okay, I see what I do wrong. I'm supposed to put 1 here. Anyway, sorry about that. It's supposed to be, no, that can't be 1. Nah. But this point probably too far down from this. You get a parabola. So this will be x squared minus 2x plus 1 is equal to x squared minus 8x plus 16, right? Plus 16 plus y squared minus 4y plus 4, right? X squared will cancel, and you can bring everything on one side. You'll get minus 2x, actually, right on that side, right? Minus 8x plus 2x plus 16 minus 1 y squared minus 4y plus 4 equal to 0. So I have y squared. Anybody get this online? Y squared minus 4y minus 6x. This is what, 15, 19? Anybody get that? The signs might be different. The signs might be different, right? Okay. All right, let's see. Hold on. Let's see this AI pick up anything. Let's see. I know if you're not paying attention to those.
I shut the last first.
Huh? I have it turn on the AI and when I turn it on, it'll search up to whatever. No, what if you on and let him out? And let him out. All right. What tell you? Oh, past paper. Pardon me, sir. -8 +2 Yeah. You'll see 2015 bottom part. In fact, here we go. The first part one there. Start with part B first, and then we do part A. Start with part B, and then we do part A. Let's see what you get. Draw a diagram to help you with part B. Yeah? If you do write the question up, please. I want to do the question, right? Let's draw a diagram on this stuff. Do B first. Do part B and then do part A. It's the 2015. Huh? Yeah. Try that fast. Huh? I put everything in the right place.
Like total x1, x2, right?
Yeah.
We could like would be 2 minus 3 or 3 minus 5. Not like to the second equation. Yeah. What we would do
Always use x and y as the x1 one all the time.
it would be 10.
I am not question.
I think as we think about this question, I have to negative values.
Right? So they give me these 2 points. So one is 0, 3, x is 0, y is 3. And the next point is 5, 2. Right? So the point P now, the point P moves so that its distance from 0, 3 is 2 times the distance from here. So let's pretend P is somewhere here. P is xy. What's important that I put it D and it 2D in the right place. So they said that the distance from 0, 3, so this distance is twice the distance from here. So if here is D, here is 2D. So it's very, very important that you have a diagram right. You see that? Huh? The diagram don't really work in marks, but the diagram will help you figure out how to find the and 2D. Okay? Take your time and multiply it out and let's see what you get. Any answer online as yet? Any answer, Samira, as yet? So take your time, work out D, and then substitute it. So Shivish, what is D? Square root of x minus 5 squared plus y minus 2 squared. And what is 2D? 2D is what? 2D is the square root of x minus 0 squared plus y minus 3 squared. Right. You know how we like to square both sides? You can do it. Right. You have to square it 2 as well. Okay? Don't forget to square it 2. Work it out. Let's see what we got. Well, hey, you only time. Do the cash flow sign up it one time, right? I will show you. I want that. My school clothes. There will be like 8. There will be no. Did I split the button? Yes. Same thing. No? But different. We have 5 days a month. Yeah, I think I switched up. So it's 2 days a month. There's 2 3-hour classes. Yeah, 10 days worth. Well, I think I had I give you more days.
So what did
I'll give you real days some module 3. I think it's time 22. I'll post it up so they can get it. The next thing party what time? Party. Oh, somebody else circle. Circle. Right, so when you square d, you'll get rid of the square root. When you square here, you'll get rid of the square root. So you'll get 4 by x minus 5 squared. X minus 5 squared plus y minus 2 squared is equal to x squared plus y minus 3 squared. That's okay? So I square the underneath, I got 4d squared is equal to x squared plus y minus 3 squared, and I substitute d squared one time. Oh. No, I put this here on the right spot. I put this equation into this equation. What's that? We'll share on the board. Right? And you will see how much easier it is to follow here. Right? Just do my favor now. Pull back out the equation. X minus 5 squared plus. And here's what? Y minus 3 squared. So square both sides, and you'll get d squared to be equal to this. And you will get 4d squared to be equal to this. All right? Once you have that now, once you have this, you can substitute equation 1 in equation 2. So I'm going to put 1 in 2. So I'm going to take off d squared, and I'm going to write this. See that, Nikolai? Right? It's equal to this here. X squared plus, expand it one time, right? y squared minus 6y plus 9. Right? So it's 4y, I got to multiply out here. X squared minus 10x plus 25 plus y squared minus 4y plus 4. Right? You can bring everything across one time, I guess. Minus x squared minus y squared minus plus 6y minus 9 is 0. Multiply everything by 4. 4x squared minus x squared is 4 minus 10x is minus 40x. 4 by 25 is 100. 104. 104 minus 9, 95. Then deal with the y squared now. 4y squared minus y squared is, right? Positive 3y squared minus 16 plus 6 is minus 10y. Deal with the constants already, yeah? Let me make a mistake here. 4 as 100 plus 16. Yeah. So it's 116 minus 9. Right? That's okay? So that's how much? 7 is equal to 0. So this is 3x squared plus 3y squared minus 40x minus 10y plus 107 is that. If you divide everything by 3, you'll get x squared, y squared minus 40 on 3x minus 10 on 3y plus okay, so you'll get something like that. So it's a circle, right? So you can see it's a circle and you can find the center and radius. All your signs up front. That's okay once you identify the circle, right? You have to identify the circle, of course.
So what do we look at? Like, we had 2 squared is equal to x minus y squared plus y minus
2D squared is here.
4.
You add it 2D up here, then you'll get something different. Very wrong. Right? So that's why the diagram is so important to tell you where to put the D and where to put the 2D. All right. All right. So if you had, Christopher, if you had the 2D up here equal to this, and you do it properly, you wouldn't get the same thing. You'll get different circles. Right? It'll be a different circle. Are you okay with that? So we're doing loci. I'll come back and do that question. Let's do one more loci now. Any questions online there? So you see how far I had to go all the way down. If you want, you could have stopped here and just say it's a circle. But really and truly, you're supposed to tell them a circle with the center and the particular radius. So you should ideally find the center, ideally find the radius one time. I know it's bad numbers, but that's a work on it. Marian, you okay with that? Emily? Caleb? All right. There was the next one I wanted to do. Try this one here, please. Part C. Ignore the rest around. I'll be able to come back and do the other thing after. Type part C.
Yes.
I don't know. Type part C. Right? So you have to figure out what the x-axis is, right? What's the equation for the x-axis basically? Y is equal to C. Right? Put the half in the right place, huh? Ah, yeah, yeah. Put it in the right place, you'll get it right equation, right? All right, so the point P moves such that its distance from the x-axis is half the distance from the origin. Finish. That's 2060. The one up there is 2060. Huh? 4. Any answers online? What you all got? Cartesian definite x and y. We already have it like that. Oh, you know what they probably did as well? They probably use Pythagoras theorem there as well. You know? 2d squared plus d squared. 2d all squared is equal to d squared by x. So we do that as well. These will cancel. So you also get satisfying part. But you can use Pythagoras theorem to create a relationship. What's that? Okay, huh? Well, I know what you take right here, 2016, module 2, number 4. Oh, we got online?
Yes, sir.
Huh? So I have 2d is equal to the square root of x minus 0 squared plus y minus 0 squared. And d is equal to the square root of x minus x squared plus y minus 0 squared. Right? When you square both sides, you'll get 4d squared is equal to x squared plus y squared. And you square both sides here, you'll get d squared is 0 plus y squared. Right? This equation. Right? Do the usual thing. Substitute equation 1 in 2. But sorry, 2 in 1. Right? So you'll end up with 4y squared is equal to x squared plus. So again, 4y squared minus y squared is. So you're getting 4y squared is equal to. Sorry, 3y squared. Thank you. 3y squared is equal to x squared. That's it. Okay, next one. How are we doing this next part here? All right. So that's your locus. That's the way you handle your locus, right? Trouble killing. Very good. You got it? We means that here.
Yes.
Any questions online? But I want you to identify Timothy, right? Timothy, what's really important there is the diagram. If you put the half in the wrong place or the 2D in the wrong place, you get the whole thing wrong. Same question. Any questions there online? I'm going back to the past paper, right? What year was that again?
2016.
Oh wait, we didn't get to do this one. Anyway, let's talk about 2016. Oh wait, that's 2015. Look at this one here. They gave you a line. They gave you a line for D. They said that the line and the circle confirm you was speaking language. What? I speak in English.
That's it.
Can you figure that out? Right? The line 2x plus y plus 3 is 0. And the circle x squared plus y squared is 9. It's a really point of intersection. What? Huh? Right. So substitute the line and the curve and solve, right? That's okay? That's all you have to do. Substitute the line, the curve and solve simultaneously. So I'm not too interested in that one, right? I am more interested in this one here. How do I get, there are two circles, right? Right, there are two circles. How do I get the Cartesian equation, Shivish, on the parametric? How do I get the Cartesian for this one and for this one? Shivish, how do I go from parametric to Cartesian? Huh? Sure, you know what you're telling me. I'm going to ask you something else. What are you going to do? Take cos theta the subject and then what? And substitute into what? And then you're going to substitute into sin squared theta plus cos squared equal to 1 7. Oh yeah. Get these two Cartesian quickly. Now remember how to identify the parametric. Suppose it didn't say this here. How would you know it's a circle? Right, the value in front here is the same. Right? The value in front, the cos and sine is the same. And what about if the values are different?
Yeah.
It'll be a what? Ellipse. Nice. Right? Do me a favor. Just find the Cartesians there and then we'll just talk about how to solve them. Right? That's if you do vectors. But if you can revise from 5 vectors, I'll go it over, but in 3 dimensions.
One part of it.
What does that mean?
Something like
What if I skew or something? Oh yeah. Find cos and sine and will get you there. Did I teach in a certain way? I teach in a certain way. Selectividad. Selectividad. Pero no mucho de esa. Stefan. Stefan gets it. Yes, we did first. It's good. You have to do because one of the same frequency. right, they do it. Right, so what do we have? From here, we have cos theta is equal to x plus 3 on root 10. Here we have sine theta is equal to y minus 2 on root 10. Right? Square both sides and square both sides and make it equal to 1. Right, remember cos theta plus sine square theta is 1, right? Square both sides and multiply everything by square both sides and multiply everything by 10, sorry. And you'll get x plus 3 squared plus y minus 2 squared is 10. Okay? Yeah, I just squared both sides and multiplied by 10. Okay? And next is what? Next is x minus 3 squared, right? Y minus 2 squared and multiply by 16. Okay? All right, before the getting lost, right? This is all I'm doing, right? Cos theta is equal to x minus 3 and 4 after square that. Right? And then you will get the sine theta, that'll be y minus 2 and 4 squared up. And then you have to add them and make it equal to 1. When you square the 4, you'll get 16. So you multiply everything by 16 together. Right? And then to get the point of intersection, how are we doing it?
Substitute each other.
Substitute one to the next and solve simultaneously. But wait. Before you do it, something you have to do. Whenever you have two circles, right, and you have to solve simultaneously, you have to subtract the two circles first and get a line. Then use that to make x or y subject to the formula. Right? So for homework, I want you to try that, please. Right? So subtract C1 and C2. Write it down. Subtract C1 and C2. Subtract C1 and C2, and then make y the subject on the line and finish the homework.
Yes, sir. Next we got good.
No, we have to do homework.
Yes, after.
And Shivish because you know homework Friday. Yeah? You have until Friday.
Right.
Shivish. All right, online. So